Hey guys, in this video we'll be looking at graphs of trigonometric function. We're going to look at the changes in a values, b values, c values, as well as what happens when we add a negative to a trigonometric function graph and modulus as well. Let's get right to the questions. The first function we have is y is equals to 2 minus 3 modulus sine of x. The strategy that we're going to use here is you're going to start with the basic graph, that is, if the graph of trigonometric function was just the trigonometric function of x. In this case, that would be y is equals to sine x. So let's start with y is equals to sine x. You start with the function and we work outwards. So sine x, the graph of sine x, we have to be aware of the range. The range for the question is 0 to pi. Pi radians is 180 degrees. So this is the range that we are going to draw our graph. And for sine x, we have your 5 basic angles, your 5 important angles, 360, split that into 2, 180, split it into 2, we have 90, and 180 plus 90, that is 270. These are our key points when drawing graphs of trigonometric function, whether it is sine x, cosine x, or tangent x. Let's draw y is sine x first. This is the y-axis and the x-axis. For y is sine x, we have an amplitude of 1. And the graph is 0, 1, 0, minus 1, and 0. So we get sinusoidal graph like this. This is just a rough sketch, so we don't have to be very accurate with it yet because we're going to make changes to this graph. So this is our basic graph of y is equals to sine of x. Now we work outwards. So the next thing outside, just outside sine of x, you can see we have this modulus. What we do with the modulus is anything in the negative y region, we flip it so that it is positive. That's what we do with modulus. So as you can see, this is in the negative y region. This value of y is negative. So this portion of the graph needs to be flipped over. It is reflected in the x-axis over. So what we get is the new graph will be, this portion of the graph remains the same. However, this one will become like this. So since this is negative 1, this will be positive 1. It is the same amplitude. So this is y is equals to modulus sine of x. So let's erase our first graph. Let's get rid of the first graph. Okay, so now this is y is modulus sine x. Now we apply the next change. The next change here will be multiplied by 3. And when we multiply by 3, this is a change to the a value. If we take our general form, we will have y is equals to a sine of bx plus c. In this case, this is a change to our a value. A represents the multiple to the amplitude. The original amplitude of the graph, this is y is equals to sine x is 1. So if you have an a value of 3, as in this case, that would mean that the amplitude is increased 3 times. So the amplitude, the new amplitude for 3 will be 3 and negative 3. So this is applying the change 3. So now we have our graph has been modified again. We have y is equals to 3 modulus sine x. From here, we expand out some more. You can see we have a negative sign. What do we do with the negative sign? When you add negative to the whole thing, what we are doing is, this is a complete reflection in the x-axis. Here, it is not just the negative region that's going to be reflected. It is the whole graph. Whether it's negative or positive, we just flip it over, reflection in the x-axis. So what will happen to this graph? We use a different color here. When we add negative here, negative 3 sine x, modulus of sine x, we get this here. So now the whole graph is flipped, and this is our new graph. So again, our values here, we have negative 3 and negative 3. And now we work out even further. So we go out. The last change that we have here is 2. You see the number 2 here. So if we rearrange this, this will be y is equals to negative 3 modulus sine x positive 2. So the positive 2 value here is actually our C value. C values represent vertical movement of the graph. The whole graph is going to move vertically. It is a translation. If the C value is positive, we'll be moving up. If it is negative, we move down. And therefore, since we have positive 2, the whole graph is going to move up by 2 units, plus 2 units. So the key points, we take all of our key points again. From negative 3, if we go up 2 units, this will become negative 1. Use red again. So this will be negative 1. Our points here will be negative 1 and negative 1. This is where they will end up. And what happens to these points? These points are at 0. So from 0, we plus 2, they will end up at 2. So we have 2, 2, 2. And now we can draw our graph. 2 to negative 1 to 2 to negative 1 to 2. And this is the final graph after all the changes have been made. But we are still not following the requirement of the question because this is from 0 to 360 degrees. Our question has asked us to draw the graph in the range of 0 to pi. So 0 to pi would mean we only go up to 180 degrees, which means the portion of graph that we need to sketch is until here. The actual answer will be, we have y against x, and this time we are going to use radians because the question has asked us to draw for the range of x between 0 and pi radians. So we will put 0 here and pi. So the only other important angle in between will be pi over 2, which is 90 degrees. And that's all we need to label. Now we need to label our actual graph. So the final graph here, based on the working that we did just now, we start with 2, and then at 90 degrees, which is pi over 2, we have negative 1, and then 180 degrees, which is pi, we have 2. So this will be, let's label this 2, first point, pi over 2, it should be at negative 1. So let's label the next point here, and then it should go back to 2. And this is how you label it. Now let's draw the graph, sketch the graph. So we go from 2 to negative 1 and then back to 2. And this is the graph of y is equals to 2 minus 3 modulus sine x for the range of 0 to pi. Let's try the next one. Y is equals to negative cos 2x minus 1. Here you can see we have introduced a different kind of change. Y is equals to a cos bx plus c. Here you can see there is a change. So we start with our core graph first. So let's start with y is equals to cos x. Again, this is just our rough working, so you don't have to draw nicely. Just roughly sketch. You can use, if you're comfortable with radians, you can straight away do it in radians. But I find that most of my students still prefer degrees. So you can do your rough work in degrees, no problem, as long as you remember to convert back. 180, and then we have 270, and then we have 90 degrees. These are the 5 important angles that you must do. And then we start with cos 2x. So if we are starting with a graph of y is equals to cos x, start with cos x first, the basic graph. The y equals to cos x has an amplitude of 1. It will be 1, 0, negative 1, 0, and 1. This is how the graph should look like. Okay, this is a sketch of y is cos x. Now, again, the strategy here is to start from within and move outwards. So we have cos 2x. Let's look at the first change. 2x. B is the value that is linked to the period. So the period of the graph will be equals to, for sine graph and cosine graph, it is 360 degrees over the b value. If the b value is 1, for example, in this case, y equals to cos 1x, this is 1, then the period of the graph will be equals to 360 over 1, which is of course still 360. This is one period. We have one complete cycle in 360 degrees. Whereas in this case, if it changes to 2, then the new period will be 360 degrees over 2, which is 180 degrees. This means we have one full cycle of cosine graph in 180 degrees. So what does that look like? Let me draw over this first. So our full cycle will end here at 180. So now that means we have to halve all of our key angles. From 270, this will become 135. Here in between 135, and from 180 this will become 90, and from 90 it becomes 45, and of course 0 is still 0. So our new graph will look like this. We have one full cycle in 180 degrees. Now what happens from 180 to 360? You will have another cycle, because one full cycle is 180. So the next 180 you have another full cycle. So again you draw the angles in between, plus 45. So this is 225 degrees and this is 315. What I'm doing here is I'm adding 45 degrees, because this is 90 degrees. 180 to 270 is 90, 270 to 360 is 90 degrees. So when we want to half that, we have to add 45 degrees. And now we will have here, and then we have it here, and here, and here. So our graph will look like this. This is what y equals to cos of 2x looks like for the range of 0 to 360. Again, we are starting off with 360 because we want to work off our standard graph of cosine. That's y is cosine x from 0 to 360. That's the usual graph that we start off with. And then we go to the next change. So the next change that we have here, we work outwards, is negative. Now we have to add negative to cos 2x. Just like earlier, what we got to do when we add a negative in front of it is to do a reflection in the x-axis. So we are going to flip the graph. We're going to flip it vertically. What happens here is, let me erase our original graph. This is gone. This is our new graph. Now we have to flip this. So when you flip this, we will get 1 will be negative 1. This is still 0. Negative 1 will become 1, 0, negative 1, 0, 1, 0, negative 1. So when we flip it over, it's a reflection. This is the graph that we will get. This graph is y is equals to negative cos 2x. So now we can erase our old graph. We can get rid of this. Okay, let's look at the final change. The final change is minus 1. This, negative 1. So again, this is a change in the c value, which is a translation, which is a vertical movement of the graph. And since we have a negative value, we are going to be moving down. So let's move down by 1. When we move down by 1, what we're going to get is 1 will become, we're going to move down, negative 1. So 1 will become 0. Anything in negative 1 will become negative 2. So let's extend this to negative 2. So this will come down here. Everything, it was originally negative 1, will become negative 2. And we have our important points here. 0, all the 0 values will become negative 1. So we have one point here, 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 and here. And of course, all the points at 1 will become 0. So we have points here and here. So let's sketch our graph now. So we have a graph that looks like this. This is our final graph. So this will be y is equals to negative cos 2x minus 1. So again, when we want to draw the graph, when we want to answer the question, we need to follow the range in the question. The range in the question is from 0 to pi. Still the range. It will be the same range for everything. So when we're doing 0 to pi, we only take this portion. until 180. So that will be here. We take this portion. So let's move our working aside. Now let's sketch the graph. So we are going to use y and 0 to pi. So we put it in radians. X will be in radians. 0 to pi, 0 to pi radian. In between we have pi over 2. Now in this case, remember, because it was 2 periods in 360 cycle, so we're going to add the halves of this as well. So we will get pi over 4, and here we have 3 pi over 4. These are important points. Now let's sketch the graph. So for here, as we look at our working, we start with -2, and then we go to -1, 0, -1, and -2. So let's start with -1 here, and then we go down to -2. Alright, so 0 you have -2, and then 1, -1 is pi over 4, 0, and then -1, and then back to -2. So let's just do that. And then we sketch the graph. And this is our graph. This is the graph of y is equals to negative cos 2x minus 1. By the way guys, if you're getting value from this video, I would really appreciate it if you just hit that like button. Really does help the channel a lot. Thank you very much for doing that. Let's try the next question. Let's look at the tangent graph. This is y is equals to modulus tangent half x minus 2. So let's write our basic form first. Y is a tangent x, tangent b x plus c. So for tangent graph, let's draw our graph, standard graph for 0 to 360. This time I'm going to use radians. So we have 2 pi, pi over 2, and 3 pi over 2. Alright, so for the tangent graph, you have two asymptotes. Asymptotes will be at, we are going to draw y equals to tangent x. Asymptotes will be at 90 and 270. So that is pi over 2 and 3 pi over 2. Asymptotes are lines where the graph will never touch. The graph will never touch the asymptote. And so we go up from 0, we start by going up, and then we go from down. So don't touch the asymptote, we go to 0, and then we go towards the asymptote again, asymptote back to 0. So this is a graph of y is equals to tangent x. So again, we start from within and we move outwards. So we have half here. For tangent x, this is a change in the b value. For tangent x, it's a bit different. The period is equals to 180 degrees over b. This is because the period of a tangent graph is 180 degrees, not 360, as you can see clearly from here. The full cycle is only 180 degrees before it repeats itself. So that is one period. And so when we have half, let's substitute that. The period here will be equals to 180 over half, which is double of this, which is 360. And so we now have one full period is equals to 360. So how do we do that? So when one period fits into 360 degrees, what happens is we have to double all our values. Because originally one period fits in 180. Now it fits in 360. So we have double all our key points. The asymptote from 90 degrees will now become 180 degrees, pi radians. For 270 it becomes 540 times 2. But 540 is outside of our range, 0 to 2 pi, so I'm not going to draw that. Then we move on to this 0. So 0 will still be 0. But now we are going towards the asymptote here. So it goes like this. And then our next point here, for 0 it was, for pi it was 0. So now this will become 2 pi. At 2 pi it is 0. Pi times 2. And this is where we will get coming from the asymptote here. And that's it. For 0 to 2 pi, this is what will fit inside 0 to 2 pi. So let me get rid of our old graph, first draft. This is done. Okay, and now we have y is equals to tangent of half x. The next thing to do, let's see what's the next change. The next change is to work our modulus. Alright, so let's work the modulus. For modulus, once again, anything in the negative y region needs to be flipped, needs to be reflected in the x-axis. So the only thing in the negative y region is this, and this will become like this. We have flipped it in the negative region. This is gone. Okay, so now we have modulus tangent of half x. Y equals to modulus tangent of half x. And then from here, there is one more change that we need to do, that is minus 2. So once again, this is a C change. A C change is a translation, it's a movement, vertical movement. And since this is negative, we are going to go down. So we are going to go down by 2 units. That means whatever was originally, so what is originally 0 would become negative 2. 0, this will become here, and then this is 0, this will also become negative 2. The rest is a line approaching the asymptote, so it goes to infinity, so we don't have to label that. So what we do here is we do this, we go up towards the asymptote but never touching the asymptote and come down. Now we have to answer the question and draw from 0 to pi only. So let's move our working as, and then we label pi and 0. So now we mark our key here. Our key here is, first we mark the asymptote. So the asymptote is at pi. Let's mark the asymptote. So we have this asymptote going on at pi. Alright, then next we mark our key point is at 0 is negative 2. So let's mark that. 0, it is at negative 2, and that's it. So we are going up. So we go up here from negative 2, we go up approaching the asymptote but never touching the asymptote. So this is a sketch of y is equals to tangent, modulus tangent of half x minus 2. Finally here we have y is equals to negative sine x plus 1. When y is equals to negative sine x plus 1, let's start with y is equals to sine x. So once again, I'm going to use radians here. So we mark it with 2 pi, pi, 3 pi over 2, and pi over 2. If you're not comfortable with radians, I would recommend doing some practice so that you are more comfortable with it. But if you really are finding it difficult to wrap your mind around it, you can use degrees first and convert to radians later. So here we have y equals to sine x again. Y equals to sine x has an amplitude of 1. So we start from 0, 1, 0, negative 1 and 0. This is our original graph. You don't have to draw it too nicely. Okay, we're done. And this is our basic graph of y is equals to sine x. So again, we work outwards. The first change here is the negative sine x, which means we flip the whole graph vertically. So there is a reflection in the x-axis, which means we get this. This is y is equals to negative sine x. So I can get rid of our original graph. And then from here, the only change is the c change, plus 1. So from here, all the 0 values will become 1. So we have 1, 1, 1. Let's get rid of this. And then all negative 1 becomes 0. We're going up. Plus 1, and then 1 will become 2. So this is actually 2. This is just our sketch, it doesn't have to be nice. So we go up to 2. So now we can get rid of this. Now this is y is equals to negative sine x plus 1. And now we answer the question. We only have to draw until, mark our important points. So until pi, we are only going to take this portion of it. So 0 to pi. So we have 0 is 1. And then we have pi over 2. Pi over 2 is 0. And then we have pi is 1. Pi is 1. So this is our graph. We're going down here. And then we go back up here. This is a graph of y is equals to negative sine x plus 1 for the range of 0 to pi. That's it for this video, guys. I hope you've learned something. If you have, please don't forget to hit that like button. Thank you very much for doing that. I'll be producing at least one video a week. If you enjoy videos like this, do subscribe. See you guys in the next video.